Chipset design versus motherboard implementation. We have another subscriber question we're looking at today, and we're going to go through, and as we read the comment, once we understand what we're working with, we've got to outline our resources for the motherboard, for the processor, for the chipset. And then what we're looking at on this one side are the PCI Express resources to the CPU and the PCI Express resources to the chipset. Okay, once that's set aside, then we've got to look at it on the other side, because it's a two-part question. What does it take to add storage beyond what's obvious on the motherboard? That's why we have to know specifically motherboard brand and model. Fortunately, this is ASUS, but it's still on a Z690 chipset. I got to say, I'm not impressed with the Z690 chipset based on all the implementations we've seen. I like the way it looks on paper, but I don't like any of the implementations. This is no exception. The documentation on this is a little bit harder, but of the things we're looking for, of about 6 or 7 things, we're going to go through with all the information we've got, because we're going to look for some congruency. In other words, if I can verify certain things I'm looking for in several places, then I know I've got something to work with. Now, whatever we find with documentation, the only thing that matters is what you see in the BIOS, because the BIOS, that's absolute. And sometimes we get some obfuscation. So let's go read the comment. And this message is on our video about the ASUS Hyper M.2 X16 quad card PCI Express 4.0, and this is about restoring performance. And this comment was from Devin Oracle X. At BuildOrBuy, your videos on setting up the ASUS Hyper M.2 X16 quad card 4.0 and its performance results have been great. Thank you. My question for you is setting up this card on the ASUS Prime Z690-P Wi-Fi, so that's going to be the title of our video, as well as Thunderbolt, because this motherboard supports Thunderbolt. We'll get into that when we get into the resources. In either the PCI Express 5.0 X16 slot or the PCI Express 4.0 X16 slot. And what read-write performance you'd think I'd get using 4WD Black SN850 2TB NVMe PCI Express drives as a striped RAID boot drive or as a striped RAID scratch D drive. Thanks. And my comment to Devin Oracle X, welcome, stellar. Our response requires a video to explain how this works. So you have to remember how we have to sort all this out. We have to look at all the resources that you got, put that in one category. Then over here we have another category, are the resources that you need. And the two things we're looking for are CPU PCI Express resources and chipset PCI Express resources. We've got to have all the information outlined, so then we know what we've got to work with, so we can figure out the what ifs and what the options are. It doesn't get easy on the Z690 chipset. In fact, these motherboards that have shared resources are a lot more complicated and convoluted than on a motherboard that has dedicated resources. But there's always more than one way to look at this and try to figure out a solution to the problem. Back to the comment. There are 2 parts. Actually, there's going to be 3, but from what I commented, there's going to be 2 parts to the question. We need to cover this once we can verify the motherboard. Is this the one, and is this your CPU? Have not heard back from him, so we're going to go on this based on what we think this needs to be. Okay, the first thing, we've got to figure out the motherboard and what the resources are, so we're looking for information that we can verify. And this motherboard, of course, is the ASUS Prime Z690P. Now, the specificity on that model number is extremely important as we go through the information we've got to outline. We're going to go to tech specs, CPU, we're going to get more into that, memory, 4 DIMMs, dual channel, supports 128 gigs. Graphics, that could go 2 ways, but based on resources, we're going to do what we think will best suit this situation. DisplayPort and HDMI, so make note of that, because remember this motherboard supports Thunderbolt. Okay, right here, expansion slots. This is what we've got to focus on. 1 PCI Express 5.0 by 16 slot, that's mechanically and electrically. Then through the chipset, everything else, to reiterate, is through the chipset. 1 PCI Express 4.0 by 16 slot mechanically, by electrically it's by 4. And then we have 2 PCI Express 3.0 by 16 slots mechanically, electrically they are by 4. And then 1 PCI Express 3.0 by 1 slot. Storage, our options include to the CPU, M.2_1, then through the chipset, M.2_2 and M.2_3. I don't see any shared resources. The only asterisk here we have is Intel RST for RAID. I need to go ahead and mention this. NVMe RAID 01 and 5 and SATA RAID 01510. Without having the motherboard in front of us, I cannot verify other than what I can read. In other words, NVMe RAID should support 10, but I don't know that for a fact, to reiterate without seeing it. And up here we also have 4 6 gigabit SATA ports. So each one of those is a PCI Express lane, so that's 4 lanes. So right now through the chipset, we have 4, 8, 12, M.2_2 and M.2_3, and 4 SATA ports. And then we have the 4 lanes for the M.2_1 to the CPU. PCI Express 4.0. That's important to note. We have to remember this is Intel, so we're going to see a combination of PCI Express 3, PCI Express 4, and PCI Express 5. And it's just kind of all over the place to figuring out who's on first. So I want to make note of all that. These details matter. Our Ethernet is 2.5 gigabit Ethernet. That's going to be a big deal when we get to the BIOS, because the BIOS manual for this is generic. Wi-Fi, 1 PCI Express lane, USB, and the most notable part on the USB, this has 1 USB-C port, 20 gigabit. That's what the 2x2. We're going to do another video about that. But that's one thing to note on this motherboard that's interesting, curious, and that's a positive. Not all motherboards have a 2x2. And this, according to the instructions, says it's on the rear I/O panel. A lot of times you'll see the 2x2 port on the internal port that goes to the front of the case, not this one. And then, of course, the USB 3 and the other USB 2 ports. And bandwidth. That term is important as we look at these devices. This is all about USB 2. 2 USB 2 headers, which is good for 4 USB 2 ports, and all 4 of those are shared the bandwidth. So keep that in mind. Okay, let's go over to support. We're looking for manuals. Depending on the manuals we find, web storage insert page, we don't need that. A BIOS manual, we're going to need that. It's not as specific as I'd like because it's generic about the chipset, which is a bit of a problem, but we'll get to it and I'll show you the differences. The user's manual and a quick start guide. So we only need 2 of these, user's manual and the one about the BIOS. If you'll note the marks while we're here on this manual, this is the manual that's intended to be used for print, because when you see those marks like that, there will also be a color chart somewhere in here to do the for print color process. This is not normally the manual that's put up on the website to be downloaded as a PDF. This is the one that's to be used, to reiterate, for print. And I think because of that, that creates some of the issues for some of the specificity. The manual should be the same. Only thing that should be different would be the color markings. But because of some of the information is not as clear and concise as we'd like, we have to consider that. So consider the source as we share this with you. First thing we want to do is go to page 3 for contents. We'd like to have a chipset block diagram. It'll be listed first. It's not here. So we'll move on to number 2, product specifications. We'll go to that. And again, verify the same information about the CPU, the chipset Z690. We're going to go to Intel and check that out. We'll also go to Intel and check out the processor based on the one we think is most appropriate in this situation, because there's a lot of information we don't have. To reiterate, when you guys ask us a question, we need clarity on the brand, model, and a lot of times revision of the motherboard, especially when Thunderbolt's involved, because all those details matter. And when we're trying to figure out resources for PCI Express to the CPU and through the chipset, all those details matter, because the better clarity you give us, the better clarity we can have on the answer we provide. So to reiterate, memory 4 DIMMs, 128 gigs, and this is DDR5. Make note of that. Dual channel. And for the video, we have DisplayPort and HDMI. That'll be important when we get to it. And looking at our expansion slots, 1 PCI Express 5.0 by 16 slot mechanically. Through the chipset, everything else. And check the bifurcation table and support site. That is a very key piece of information we're going to have to check. That chart, a lot of times we refer to, but we don't always show it. For this video, we're going to show it because some of the information is a bit of an obfuscated mess. And, well, just make note of that. We'll come back to it. All the details we share are going to matter when we start looking at this. Looking at our stars and our asterisks here, we've got 3 slots through the chipset as we're looking at storage and the 4 SATA ports. And then the M.2_1, to reiterate, is to the CPU. Good to know. And it's PCI Express 4. And M.2_2 is PCI Express 4. M.2_3 is PCI Express 4. Good. That would matter if you decide to do RAID. You wouldn't want one slower drive slowing down the faster drive, so those can be equally matched. Now that's on page 6. We're going to go to page 14 and look at the motherboard layout, and you can see markings for color layout at the top, as I had mentioned earlier. Okay, I like to physically see what we've got on the board. If I had any concerns or doubts, then what I would do, I would go look for another motherboard, someplace like Newegg or even Amazon or a B&H, someplace that gives me a good representation. Okay, by the slots, 1, 2, 3, and 4. Let's get all 4 of those so we can see them at the same time. Okay, to reiterate, 1, 2, 3, and 4. And the top one is PCI Express with 16G5. That's a 16-lane slot mechanically and electrically. These other 3 are 4-lane slots electrically, and that's what matters. M.2_1 is on the top. M.2_2 is second, and then the M.2_3 is third right here. And all 3 of those can be up to, well, let's see, the first one and the second one can be, right here, the first one can be 22.110, the second one can be up to 2280. 2280 is normal, and the third one can also be up to 22.110. I've yet to see one of those. And notice the numbers, PCI Express was 16. I'll zoom in on that a little bit. PCI Express was 16G5, G3_1, G4, and the third one is G3_2. Now this slot, while we're here, also has, if you notice, the TB header. Typically, normally, not always, but typically wherever your Thunderbolt header is, if it's, say, on the bottom of the board like this one, could be over to the right edge. Whatever slot is closest to that header is normally where that needs to be plugged in. We'll look at another note that'll talk about that in just a minute. And sometimes there's an addition at just below this that will tell us about the slots, and this motherboard layout manual is different. So we're going to skip on down to page 19. I had to do a lot of digging in this manual. That's why I know where everything's at, because they didn't make it easy. So we're going to look at expansion slots, and we're going to have to bounce back and forth on this, because what we want is right here, the recommended VGA configuration. I'm going to zoom out on that just a little bit so we can see all of it. Now, 1, 2, 3, and 4 to the left across the top. Now, to reiterate, remember, first slot, PCI Express 5.0, that's the top slot. Single VGA by 16, dual VGA, triple VGA. Okay, as we go down the tree, number 2, PCI Express 3.0 by 16_1. Not used, not used, not used. Now, I'm going to go back up here to the chart. PCI Express by 16_1 is the second slot right under the G5. That's G3. G4, and then the G3 down here, _2. So you get these 1, 2, and 3 slots. Okay, back to the chart. Number 3, PCI Express 4.0. Now remember, first slot's PCI Express 5. Second slot right next to the GPU is PCI Express 3. Third slot, PCI Express 4. And the last slot is PCI Express 3. Now remember that last slot, number 4, PCI Express 3, is where the Thunderbolt card can go if you choose and decide to put it in, and that's Thunderbolt 4 support. We're going to get more into that. Hold on with this. Number 3, PCI Express 4.0. Single VGA. In a dual, you have a 16-lane slot, and the other, whatever, is going to be in a 4-lane slot. All 3 of those slots, to reiterate, are 4-lane slots. Only the top one is a 16-lane slot. Keep that in mind. And if you want to do 3, it says VGAs, but if you want to use 3 devices, you're going to get 16 lanes out of that first slot, PCI Express 5. And then you've got in the third position, the PCI Express 4 slot, because remember you skipped the one right next to the video. That's a 4-lane slot. And then the third slot, 16_2, which is where Thunderbolt goes because it's PCI Express 3. And Thunderbolt, PCI Express 3, Thunderbolt 3 and 4 are both based on PCI Express 3, to reiterate. So those are both 4-lane slots. So you got 3 4-lane slots and 1 you don't use at all. Curious. And remember, all 3 of these are through the chipset. So the chipset is supporting PCI Express 3.0 and PCI Express 4.0. I know, confusing. Now, while we're at this point, you got PCI Express 5 on this motherboard. PCI Express 5, 3 options. 1, you got DDR5 memory. Number 2, you got PCI Express 5 on a slot that's 16 lanes. The PCI Express bus for version 5.0 is no longer about the GPU, it's about the M.2. And this motherboard does not support a PCI Express 5.0 M.2 NVMe drive. So I don't really know what you gain for the benefits of PCI Express 5 other than you can say, I've got PCI Express 5. Maybe you got more expensive memory. When we build a machine for purpose-built for content creation, none of those specs ever talk about speed. It's always about the quantity. Quantity of CPU cores, quantity of RAM, and the quantity of GPU RAM, video RAM. So this chart is very telling, but it takes a minute to soak in the depth and brevity of what you've got, but what you ain't got. And that's what's disconcerting. But we are by no means finished yet. Now we're going to do a search on the term bandwidth. Remember, we found that earlier. And the only thing in this manual that relates to bandwidth, back here on page 7, looking at the specifications, deals with those USB ports, which is understandable, they share bandwidth. But if we search for that term again, nothing. There's nothing. So the next thing we want to look for, we're going to have to go to the BIOS, but while we're here, I'm going to do a search for Thunderbolt, and we're going to cover that information while we're in the manual. Okay, there's a Thunderbolt header, as we've outlined right there. So to reiterate, that's where the Thunderbolt 4 card would go, and specifically, it has to be the ASUS Thunderbolt 4 because that's a 14-1 pin header, and Thunderbolt is vendor specific. Now, we've got separate videos about Thunderbolt 3, Thunderbolt 4, and how all that pinout stuff works, but just suffice to say, Thunderbolt 4. But there's a setting in the BIOS we're going to take a look at among some other things we're looking for, because one of the issues with bandwidth we're looking for we don't find that deals with those slots. Another issue we're looking for, because I'm looking for information as it relates to adding storage for the quad card that I'm not seeing. But we're not done yet. So let's continue our search for Thunderbolt in the manual. And it talks about the Thunderbolt header. And this is on page 32. Shows the 14-1 pin, which is down there on the bottom. Specificity, the add-on card for Thunderbolt. Okay, here we are. Thunderbolt can only be used when installed in the PCI Express 16 G3_2 slot. Ensure to install your Thunderbolt card in that slot, and that slot only. And that's the slot that's PCI Express 3. It's only 4 lanes, and it's the slot right there next to the connector, if you choose to install it. Now, what's curious, a lot of times when motherboards have resources, as we outlined, first of all, we look at slots, PCI Express slots, then we look at M.2 connectors, but then we look at certain devices, things that normally take up 4 lanes, like if you had, in this case, Thunderbolt. Normally, Thunderbolt built on the motherboard is a dedicated resource. Usually, Thunderbolt as an add-in card, a lot of times on a motherboard with shared resources, it's an either-or, just like maybe you might have 2 SATA ports. Right now, all I can tell is your SATA ports are dedicated, that's clear, and your Thunderbolt is also dedicated, that's clear. So those kind of shared resources you don't have. My next concern, because I can't find anything about bandwidth in the manual, let's go look at the BIOS manual, see what we can find out. Now this BIOS manual is generic. I do a search for bandwidth, nothing. I'll do a search for Thunderbolt, and I'll have a real nice menu in the manual about Thunderbolt. So we're on page 3, we'll click on that, and that will take us to this. And one thing I found quite fascinating in this manual about Thunderbolt, if you'll notice right here, this is under Advanced Thunderbolt Configuration, PCI Express tunneling over USB4. Now for those curious about USB4, I want to mention this. Even though that is there for support, I would expect, based on what we've seen so far, USB4 is coming on first for the laptops, which was a driver update. Therefore, I would expect a chipset driver update to fully enable USB4 in this system, but USB4, to reiterate, is going to be through the Thunderbolt 4. And that's the reason for the tunneling, so I want to point that out. So 2 redeeming qualities on this motherboard. One, you have, actually I guess 3. One, you have the possibility for Thunderbolt 4. 2, you can have USB 4 through that port. And you have also the, which is a 40 gigabit. And remember, I need to put all this in relevance. Normally USB-C is 10 gigabit. Then USB-C, where it talks about 2x2, is 20 gigabit. You have that out the back I/O panel. We'll look at the I/O panel and verify that, because placement, everything matters. And then you also have the 40 gigabit, but remember, Thunderbolt 3 and Thunderbolt 4 are both 40 gigabit. Thunderbolt 4 bidirectional, but they're both based on PCI Express 3.0. So the fact that you've got Thunderbolt 4 possibility, USB 4 through that Thunderbolt 4, and number 3, that you're going to have built onto the motherboard, 20 gigabit USB-C. Those are the redeeming factors of this motherboard. Otherwise, I'm not real happy with this motherboard. I don't like the way the resources are laid out, even though they're dedicated, because the real conundrum is, as we look at this slot, we've got to find something in the manual that I can't find, that doesn't exist. But there's another document, to reiterate, that I have referred to, that I'm going to show you, that says what we need to do is possible. Okay, hold all that thought about resources for the motherboard. Now, what are the requirements, of which there are two, when you want to install a quad card. Now, this that I keep in front of me is the Gigabyte TRX40 Designaire, where I have 4 16-lane slots mechanically, but electrically I have 2 16-lane slots and 2 8-lane slots. And in one of the 8-lane slots, I have Thunderbolt 3. These are dedicated resources. Now, all these resources are shared. For the quad card, whether it's ASUS, ASRock, MSI, or Gigabyte, all four of those, number one, you've got to have a 16-lane slot. Okay, you have one 16-lane slot. I'm going to go to PCPartPicker, and I want to verify a couple of pieces of information because we need to talk about what CPU you might be using since you didn't tell us. Okay, first thing we'll do is go to System Builder. We're going to choose a motherboard. First thing we'll do is base that on the brand, ASUS. Next thing we'll do is scroll down and base it on the chipset, which is the Intel Z690. And that brings our focus down to 20 compatible products. And the one we want, and there are 4 versions of this motherboard. We want the ASUS Prime Z690P, ATX, 128 gigs of RAM. Okay, I'm going to add that to the list. That tells us our motherboard. Now I'm going to go pick a CPU, and I always pick ZPUs based on core count. However, for the number 2 factor, because we don't know if you're using a GPU or not, and because you have Thunderbolt on this motherboard and you have only one 16-lane slot, I would not advise putting the GPU, even though the GPU is no longer the primary candidate for PCI Express 5, I wouldn't put it on anything less than an 8-lane slot. And to reiterate, you have one 16-lane slot and 3 4-lane slots electrically. So I wouldn't put the GPU in there. So what I'm going to pick is a CPU that has the most cores but also has video on board. So that will enable that feature to keep that 16-lane slot available to us. But remember, change one thing changes everything. So if we're looking at 16 cores, we need graphics on board. So based on the price of the motherboard, which is about $200, my guess is you've probably got the 2.4. If you're rendering, you should have a faster CPU, but it depends on your render engine, whether it uses the GPU or the CPU. So a middle split would have to be the top one here listed, the 12900K. We get Intel graphics, which is not great, but it is what it is to do what you want to do. And since you didn't tell me about having a GPU, I want to follow this all the way through and show you what you're dealing with. Okay, 16 cores, 32 threads. Let's verify that processor. Intel i9 1200K. We need to go to the Intel Arc. Okay, here we are with the CPU cores. 16 cores. You don't have 32 threads. You've got 24 threads. Bummer. 8 performance cores and 8 efficiency cores. Well, it is what it is. And what we want to find out is PCI Express. 128 gigs of memory, dual channel. Dual channel is getting kind of old, especially since we've had quad channel, now 8 channel. I digress. Okay, here we are, PCI Express revision 5 and 4. So the 5.0, to reiterate, is for the slot, and the 4.0, to reiterate, is for the primary M.2 drive. And it shows the configuration, 1x16, to reiterate is the 5, plus the 4 is the 4.0. Or, if the BIOS supported it, 2x8 plus by 4. But to reiterate, the way your slots are arranged, of which you have 4, 3 of them are through the chipset. Now, if you had 2 of those slots to the CPU, then we might have a chance at 2x8, which would be a primary slot by 8 and a secondary slot by 8. But you don't have that. Your BIOS doesn't support that. But I want to point that out. Some motherboards do. This one does not. Okay, so we know how that's laid out. And the most crucial part, maximum number of PCI Express lanes, you've got 20 lanes. Now your DMI, which connects your CPU to your chipset, is 8 lanes. That's nice to know. What that means is anything through the chipset is connected to the CPU through 8 lanes. That's nice. However, you've only got 20 lanes. So if you've got 16 lanes for the CPU and you got 4 lanes for the M.2 that's it. There's no more lanes to do anything with. My question that I'm getting to that I don't know yet, and that's the big $3 word, is bifurcation. What is bifurcation? The ability to split or fork. For example, in this machine where I have a 16-lane slot, when I put a quad card in here, the first requirement I have to have is a 16-lane slot, which you have. The second requirement is, of that 16-lane slot, I have to be able to bifurcate. Now, bifurcate means to split or to fork. So where I have to have 4 lanes for each M.2 drive, if I have 4 drives, then 4 times 4 is 16. I have to have 4 by 4 by 4 by 4. That 16 lanes allocates 4 lanes by a setting in the BIOS so that each drive can be seen. Now, Based on the information in the BIOS that does not exist for anything about bifurcation or 4x4 or even the Hyper, a lot of times ASUS will refer to their Hyper cards by the name Hyper, or they'll call it maybe the RAID card, which it is not. That's a misnomer, separate topic. These are I/O cards, but to bifurcate one, that information should be either in the manual or in the BIOS manual, and I can't find it. So the other document, well, before we get to that, let's go verify the chipset, what it's got. Not that it matters, but a lot of times it does, because bifurcated lanes are always through the CPU. Bifurcated lanes don't happen in the chipset, but we still like to know what's what. Okay, Intel Z690 chipset, and the specifications, we are DMI 4.0, and the maximum number of DMI lanes are 8, which is good. So we've got PCI Express 3 and PCI Express 4. We've been through that. A by 1, a by 2, and a by 4. And we have 28 PCI Express lanes. So we're good for lanes on the chipset, but we're not so good for lanes on the CPU. Now, based on what we read in the manual, and this is coming from the specification summary, right down here under expansion slots, please check the PCI Express bifurcation table in the support site. Now we're going to go to ASUS, and they have an ASUS, and this chart, which has all these motherboards listed in here, I have to know specifically the motherboard we're working with, and that's the Prime Z690. So I did a cut and paste. We'll go to the bifurcation chart. I'll key that in, and that gives me 8 instances, and we want specifically only one of the 4, the Prime Z690P. So I'll just do a search for that, 1, 2, 3, 4, and we get to number 5. This brings us down to the chart. Now this says conflicting information. That's why I want to point out what the slots are and what the assignments are, because I don't think this is going to work, and ASUS doesn't have the documentation on the motherboard that it does. But when we look at this chart, it says it will, but the slot they identify, I've got a problem with. I'm going to go back and forth and show you how that plays out, because this is the first option, but there's still another option I want to show you. That's why I could give you the short answer and say this ain't going to work, but I don't think that's good enough. I think you need the complete answer to understand why this works or why it doesn't work, and what are the obstacles we need to overcome, and how can we make this work. That's what I'm trying to do. So to reiterate, this is PCI Express bus 16 G5_1, and where's _1? We'll go back to the manual and the motherboard layout on page 14. If you'll notice, I'll scroll in on that. PCI Express bus 16 G3_1, and that says PCI Express bus 16 G5_1. Okay, the G5 is the top slot. The _1 is the second slot. The only slot this is going to work in is that top slot, G5, PCI Express bus 16. That's the primary. So you have choices to make. If you don't have a GPU, then you're going to have a CPU that's got video built into it. And I still got some more on Thunderbolt I want to get to. But as this relates to the quad card that you're asking about, that's the slot it has to go in. You can't have a GPU unless your GPU goes in a 4-lane slot. Now, you've got to be able to bifurcate that slot, and to get 4 drives, full bifurcation. So the primary slot, which is PCI Express 5, will not see PCI Express 5.0 M.2. It will see PCI Express 4.0 M.2. But to put a quad card in there and bifurcate it, it looks like, based on the bifurcation chart, let's look. If this information is correct about this slot and this capability, you're going to see 2 drives. And according to those 2 drives, if we look down here at the key, and this says based on 2 stars, and apparently this is relevant for all 4 of these models. 2 stars. Please insert the M.2 SSD drives in the Hyper M.2 bus 16 quad card in socket 1 and 3. Because of the sequential numbering of 1, 2, 3, and 4, my expectation is the BIOS bifurcates to by 8 by 8. And by 8, primary, second by 8, puts it in the tertiary. Number 2 will not be seen, and number 4 will not be seen. So what you're talking about doing is adding a quad card to a 16-lane slot, either not using a GPU or putting the GPU, to reiterate, in a 4-lane slot through the chipset, which I wouldn't do. But that would be the equivalent of having your internal GPU, like on Thunderbolt 3, in an external container. But I digress. Anyway, to reiterate, you're going to only gain 2 drives, and you're wasting 8 lanes to gain those 2 drives. That's the first option with the card you've asked about. Now your second option, because you have a 16-lane slot, don't worry about bifurcation, and I can't show you if it's in the BIOS This says it is, the manual does not. So there's some conflicting information. All I can show you is the research I've done. All the cards we talked about of the 4 brands, and the one you're looking at, requires motherboard bifurcation. The other type is a self-bifurcated card. Now, you've got a $200 motherboard, about a $500 processor. The kind of card you're looking to buy that is self-bifurcated is going to cost more than that motherboard and that processor combined. Your options for a 16-lane slot would be High Point. If you want it bootable, they've got one. If you want it, doesn't have to be bootable, it's possible. And the numbers you asked, I'll get to in a minute because I'm not through with Thunderbolt yet. But you could add 4 drives in a self-bifurcated card. That would be the easy way to do it for PCI Express 4. Now, if you were looking at PCI Express 3, Amphitech has a card, the Squid, that'll do 6 drives. We have a video about that, but it's only PCI Express 3. And then there's also the Glowtrend Sky card, which is also only PCI Express 3. It houses 4 drives. It's kind of expensive. So your best option, if you want to have more drives, to do 4 drives, to reiterate, a self-bifurcated card like High Point. So those are your 2 options. I want to get back to Thunderbolt because I want to look at the connectors on the I/O panel. Because if I don't address this, somebody will ask. Okay, looking in the manual at the motherboard rear I/O panel, number 6, HDMI, and the number 2, DisplayPort. Those are both for video out. In other words, some motherboards, because of the way Thunderbolt is routed, like if it's built on, will have video routed back in, but because this has Thunderbolt as a separate card, and because you can have a CPU that has video on board, video can be routed out. So you have the option with your Thunderbolt add-in card to either route video, which would want to be in a 16-lane slot, out of the GPU, into the Thunderbolt card, out of the Thunderbolt card, in which case you wouldn't use those ports. However, if you're using the video, to reiterate, it's within the CPU, then you're going to route video out of that CPU through one of those 2 ports. So I want to put that point out. So with a motherboard that's got shared resources, you do one thing, you lose something else. You can't do everything. With all those connectors, it's just not possible. The other issue we've got that may come up is if you want to do RAID. I've commented on that. I would not RAID the boot drive with the other 2 drives. Now you asked about speed. Okay, you can go PCI Express 4 or you can go PCI Express 3. I would get the drives that are probably the best bang for the buck, which is probably going to be PCI Express 4. Now, PCI Express 4 has gone through 3 revisions. The first revision, 5,000 megabytes for the throughput. That's really a burst mode, but that's a figure that they quote. The second revision was around 7,000 megabytes. The third revision was just over 7,000 megabytes with the, I believe it's the E18 controller from Phison. So whichever drives you want to use, consider the numbers. Now typically when we put 4 drives in RAID on a quad card, and the speed for drives usually is motherboard CPU fastest, on a slot to the CPU the second fastest, third is anything through the chipset. In other words, if it's built onto the motherboard, that'd be number 3. Then if it's on a slot through the chipset on the motherboard, that'd be the 4th speed. Not a lot of difference, but enough that if you were measuring, you can tell it, but you won't see it riding by on a horse. Now, why do I say that? If you have 4 drives on a RAID card, those 4 drives will not be the speed of 4, but they're the speed of 3. So if you have 2 drives in RAID, take about 25% off one of those drives. So if you've got 2 5,000 megabyte drives, take the number accordingly. If you've got 2 7,000 megabyte drives, take the number accordingly. Now, the drive that was recommended by AMD and Phison when they were talking about the E18 controller would probably be the Seagate FireCuda 520. But that was one of 3. I think there's about 4 now that use that. I believe the Aorus 7000 that has the graphite coating on it for the cooler, I believe it's also using the same controller. So of the information you've asked, we've told you 2 ways you can do this. I don't like any of these. I wanted to know if you own the motherboard, because if you didn't, I'd say don't buy it. 3 redeeming qualities of that motherboard don't make it worthwhile. What you want and what you need and what you guys are asking about works on a high-end desktop, which is flat, which is gone. So it's either a desktop machine like you're asking about, and some of these desktop machines get expensive for the motherboard. Jump over the high-end desktop that I have in front of me and go to a workstation, which is what this technology is built for. It came from servers down to workstations to the high-end desktop, and it's trickled down to the desktop machine. So with what you want to do and what you're trying to achieve, you got two ways you can go, but it depends on the other options and choices you've made. I don't like any of the choices, so it's quite a pot to stir that soup. There's a lot of things you got to think about if you do this or if you do that, but you can't do everything. You've got options you got to choose. When you go down that path, you got to see here how that influences out there. So I want to thank you for watching. Welcome. My name is Gil Boyd. We look forward to seeing you next video. We're out.